When solving series systems, we showed how FORM can be used to compute the series system failure probability. We can do something similar for a parallel system, and the general expression for a purely parallel system is what you see on the screen, but one has to be a little careful, because as we have seen, if there are sequence effects, if we need to consider the limit states after there has been partial collapse of the structure, then all these G's, all the individual limit states, they need to be properly defined. But as long as that can be done, we have the answer in terms of the multidimensional normal CDF. If we have minimal cut sets, so it's not a purely parallel system, but there are NC number of cut sets, and so the system failure probability is the union probability. And so then each cut set is composed of its own members. Each minimal cut set is composed of its own members, and cut set I has Ni such members, and Gij is such a limit state in the cut set I. Again, we need to make sure that any sequence effects, any partial failure, if that's how we can analyze the structure, that's how we need to analyze the structure, is taken into account when defining the respective G's. Now, this also gives us an idea that are there other approximate ways in defining or in estimating the union probability, like what you see here, P of union Ci, I going from 1 to Nc. So there are some very well-known famous bounds that are put on these union probabilities. There are the first order bounds that you see on the screen, and there are second order bounds, the second order lower bound and the second order upper bound. Basically, the order implies what sort of joint event do we have information of probability for. So if we have just marginal probabilities, so that gives us the first order bound. If we have bounds of Fi, Fj, F being the failure in the cut set I, etc., Fj is failure in the cut set J. So if we have those type of second order joint probability information, then we can improve the bounds compared to the first order bounds and get an estimate. Sometimes these bounds can be quite good, sometimes they're too wide to be useful. If you have third order probability information, third order joint probability, then we can have third order bounds and so on and so forth. These can be referred to in the literature. So to summarize, we looked at structural systems reliability in this last part of part C of our course. We are going to next start with part D, the last part. For further reading, I would recommend some of these excellent books. There is the book by Thoff Christensen and Murotsu. There is Ashish Karamchandani's PhD thesis at Stanford. The book by Professor Galambos, and the textbook that we already have mentioned in this course, the one by Melchus and Beck.